Welcome to this episode of Apis TechTips, a series of short explainer excerpts from real Apis training courses. This episode gives you a concise, logical description of network slicing, and it comes from the course Network Slicing in an Hour. Enjoy!
I would like to start us with an overall picture, just putting together some most important information about network slicing. And then throughout the rest of this course, I will be digging a little bit more into the various aspects just to give us more information. But for now, to get us started, a network slice is a logical network that is kind of placed on top. It's an overlay on an actual physical infrastructure. And the purpose of having this logical network is to have use case specific settings, which means it's no longer one size fits all. Now, these boxes that we have over here, they are supposed to represent the physical infrastructure that we are going to be using. It's just that, just to be clear, such a box, it can mean a physical piece of equipment. Compute means processing power, storage means databases, and networking means the cabling that interconnects them. So these are physical things. While such a box, it can just as well be, in effect, a specialized piece of software. It can be some virtual machine is a term that comes to my mind, but other solutions for virtualization is we can talk about containers, we can talk about microservices. These are techniques for virtualization, and these techniques can be applied to the 5G network functions or the 5G network function services. So these boxes are not necessarily a physical thing, but these are our resources. And what we are going to do now is we are going to overlay onto that actual infrastructure. We are going to overlay our, in my example, 3 different logical networks. These 3 different logical networks, each and every one of them has well-defined capabilities, and it is going to handle certain groups of services. The division, the definitions, they are going to be a result of the operator discussing with their customers what it is that they actually need. And the key thing about the fact that I have these 3 different shapes here for the 3 different logical networks, 2 words that are buzzwords over here. The network resources for a network slice are dedicated, and the network resources between different slices are independent of one another. This is the biggest benefit of actually having network slicing. So let's make sure we understand these words. Dedicated resources. What does the term dedicated mean? First of all, it can mean dedicated to certain services, which means that we prepare capabilities in this logical network to fit the needs of a certain type of application, and then we're going to call this a communication service. And for a particular communication service, we will define the characteristics. Here are the quality of service, mobility, power mode saving, power saving mode, battery saving, these kind of things. These not so visible, there is 3 dots over here. A list of characteristics can be really, really long. So you can have resources that are dedicated to a particular service or application. Fine, this is what I'm kind of talking about all the time. But the other part of the statement carries yet another benefit of network slicing with it. You can have resources dedicated to different customers. And this means that we are kind of, a network slice becomes a business proposal, becomes something tangible that an operator can sell to another company and put a price tag on it. These customers, the term verticals started being quite big in the 5G environment. These are just simply different business players of a certain type, let's call it that. We'll talk more about verticals later on. We can have something, this is a term that appears from time to time, private networks. You can have a network slice can be offered as a service, and then it can be, for example, a private network, and that's the next term over here, network slice as a service. It's a business offer, as I say. This abbreviation you might know, Mobile Virtual Network Operator. They've been around for years, and it's basically that it's a different brand name, it's a different business, but the owner of that business sits on top of an actual operator's infrastructure. And what I'm saying over here is placing mobile virtual network operators among customers that can use a network slice. I am talking about a world in which a mobile operator has an operation and maintenance system, and somewhere there in the war room, a person pushes one button and then pop comes up a completely new virtual network, and that's all the work that needs to be done. Of course, I'm a bit sarcastic here. There is a lot of work around it, but that's the direction at least that we are heading into. So this is the fact that resources can be dedicated either to a service, to a customer. Then the other term that appeared over here, independent. This is actually blends down to another keyword in the network slicing in 5G, isolation. Independent means that things that happen in here don't affect whatever is happening in here and vice versa. That's isolation. And maybe you've noticed I'm being vague on purpose. What does it mean that things happening don't affect? Things is not a very technical term. The word isolation, a lot of people interpreted that isolation means isolation of resources. But please notice over here I've just put in that isolation can refer to a whole number of aspects. You can have isolation of functions, configurations, policies for resource usage, failure domains, security domains, and it's a big term. And basically what I'm saying is we can have isolation between slices, and this is a big benefit. This is what the operators are after. Now, speaking of benefits, I've tried to compile over here a list that summarizes what is seen as the most important things we gain with network slicing. So, the first statement, I would guess, is quite straightforward. It simply says that network slicing allows us to support these services and verticals that we have identified, like the ones in the previous slide, that they need us. So we are addressing a need of the market that we are aware of. But on top of that, the second bullet point here makes a statement, but we also have new use cases with the tool that the network slicing is. We can actually come up with new and interesting offers. So this can be both for individual customers and for enterprises, like the network slice as a service, for example, towards MVNOs. Now, the technology itself, from a operator's perspective, as we said, must be reasonably cheap. It's this whole profitability question. This turnover here, scalability, resources can be allocated according to need, and this can be done dynamically. Where does this come from? Well, from the fact that the logical networks that I'm talking about over here, they are using this underlying enabler of virtualization. So this is actually a benefit that comes together with the technology that we are using. Fewer dependencies and consequences to consider at start of a dedicated network for a new service. This is a very important statement, because if we are starting to talk about a world in which one operator of this physical infrastructure has to carry a number of logical overlay networks, this is a level of complexity that can be absolutely startling. And this statement over here says, don't worry, if you add yet another network slice onto your network, you might of course have problems with this particular network slice, but the other already up and running slices, processes, will not be affected. Which is an important statement in its own right, but it also has a side effect, and that's the last bullet point over here. If I can add a new logical definition onto a live network without affecting the other elements, well, this makes it a fantastic sandbox for testing new ideas on a live network. So this is also how do we develop our service offer made easier through the network slicing feature. Now, these are the benefits of the logical networks, and until now I was talking about the concept in a generic level, I would say. But the actual term network slicing comes from the standards of a third-generation partnership project. So to stick to the naming convention, we have to know where does the naming come from. And the network feature in the 3GPP standards of overlaying logical networks did not start in 5G. We are having a course about network slicing, but I just want you to be aware of the term dedicated core networks, sometimes referred to as DECOR. Dedicated core networks is a equivalent feature that was actually introduced for the 4G environment, so it was for the LTE, as we call it LTE, for the evolved packet core. And then these definitions, they can also be applied for 2G and 3G. Having said that, dedicated core networks is something that exists, but pretty much just on the paper or in form of bits in files. To put it mildly, it's not heavily used. But the corresponding, what is called network slicing, the corresponding solution in the 5G, this is actually viewed as the absolute cornerstone of the extra features that we're going to get with 5G. So almost unused here and expected to be a basic feature in 5G. Interesting thing, we've just simply evolved to the point in time when deploying this makes a lot of sense to us. Now, this is a small picture which is supposed to show us an overview from an architectural perspective of what is a network slice. So you can see over here this part which is termed RAN, radio access network. I'm not trying to say that this is a cloud environment. I just use a cloud shape to say that this is one something, kind of. Radio access network with the corresponding, well, transmission, reception, and the radio interface towards an end user device. The user equipment over here, this small line, it represents an antenna. It's wireless access, it's a radio access network. And this one over here is my 5G core. And network slice is the access network part and the core network part. So it kind of spans all the way across the access and core network down to the user equipment. And I will want to show you a little bit about the support for that in a short while as we proceed. But this is just to have the basic definition. And if you look at this basic definition, have you noticed that these two network slices represented with different colors here, they both go to the same device? This is just to underline the fact that one user equipment can use multiple network slices. What's more, we expect that this is what will be happening actually. And I did mention it, but I don't want it to disappear. So if this is the slide that summarizes everything, I want this statement to appear over here. The network slicing sits on top of the underlying technology, which is the virtualization. So it's a must if we want to have network slicing. And as I said, if we have more and more and more of these logical networks placed on top of a physical infrastructure, this does introduce problems on its own right. I mean, the question is about the scalability of I call them satellite systems around the actual transportation network. And the most important, I think, satellite system is operation and maintenance. So I just placed over here so that we remember that operation and maintenance of a huge number of logical networks on our network is a challenge in its own right. So just to be sure that we understand that network slicing does introduce issues, challenges. I'm told not to use the term problems in situations like that, so challenges.
If you enjoyed this Apis Tech Tip, check out the full Apis course Network Slicing in an Hour, where this video came from. There you will get a condensed view of the 5G network slicing feature as defined by the 3GPP. It presents operational benefits and explains the technology needed to realize network slicing in 5G. To check this course out in more detail and all our other training, just visit us on www.apistraining.com.